All right. Today's lesson is going to be all about properties of linear relations. But again, we're going to start with the skill builder first, making sure that you understand how to substitute in x values into an equation. So the first example here has been done for you. So in this case, they've given us the equation y is equal to 4x minus 3. And then they've given us a table of x values in which we need to substitute that x value into our equation to get our value for y. So in the first one here, they've shown you if x is equal to -2, that means anywhere where there is an x in the equation, we need to substitute -2. So here they've done 4 times -2, which is -8, minus 3, which gives us -11. So that means that y is equal to -11. You can see they've done the same thing here for all of the rest of the values. So for some of these, you might need to actually show the substitutions. I know some of you are good at doing the work in your head. So if you are asked explicitly to show the substitutions, you need to show the substitutions. If they don't ask you to, then that's fine if you want to do it in your head and just write your values of y. So let's try the check below and see if we can do this for a few different equations. So for our first one here, y is equal to 3x plus 4. So they want us to substitute in these x values to figure out the value of the y. So for the first one, we substitute -2 in for x, so that means we have 3 times -2, which gives us -6, plus a positive 4, which equals -2. Okay, the next one, we have -1 for our x value. So 3 times -1 gives us -3, and -3 plus 4 gives us a positive 1. The next one, we have x is equal to 0. So 3 times 0 is 0, plus 4 gives us 4. The next one, we have x equals 1. So 3 times 1 is 3. 3 plus 4 gives us 7. And for the last one, we have 2 as our x value. So 3 times 2 is 6, plus 4 equals 10. So there's our first chart of values done. For the next one, they want us, again, to use the same set of numbers. Okay, so if x is equal to -2, we're going to substitute that into this equation, y equals -2x plus 5. So for the first one, we have -2 times -2 plus 5. So -2 times -2 gives us a positive 4. 4 plus 5 gives us 9. For the next one, we have -2 times -1, which gives us a positive 2. And add that with 5, which gives us 7. For the next one, we have -2 times 0 plus 5. -2 times 0 gives us 0, and 0 plus 5 gives us 5. The next one, we have -2 times 1 plus 5. So -2 times 1 gives us -2. -2 plus 5 gives us 3. And for the last one, -2 times a positive 2 plus 5. -2 times a positive 2 gives us -4. -4 plus 5 gives us 1. So that's how you would do the questions on that page. All right, let's try the next page. So our properties of linear equations. So what we did in the previous one is going to kind of all come together in 5.6. So we're looking at properties of linear relations. So the graph of a linear relation is going to be shown as a straight line. So you can see in this picture, this is a graph of a linear relation. When we connect the points, it makes a straight line. Okay? Now we can find patterns in the table of values for linear relations as well. So if we take a look at this, we can see that the pattern on the x side is that the x goes up by 2 every time. So we go from 0 to 2, 4, 6, 8, and so on. We can see on the y side that the y changes every time by a value of positive 2. Okay, so you'll notice here on the linear relation that the changes are the same as we go from row to row, okay? So it increases by +2 every time, where on the y side, it increases by +6. So the increase on either side needs to be the same as we go up by each number. So we'll take a look at the next example and try and determine if this one is a linear relation or not. Okay, so it says, does this table of values represent a linear relation? So in order to determine that, we need to look at the left side and the right side, what they go up by each time, and if they increase in value the same, not the same amount, but if the x side is constant and the y side is constant by what it increases by, then it is a linear relation. So let's take a look. From 0 to 2, oh, that's +2 every time. From 2 to 4, oh, that went up by another value of 2. From 4 to 6, that's another value of 2. And from 6 to 8, that's another value of 2. Okay, so in order to find the difference of them, you would just subtract the second value from the first value. In this case, 0 minus 2 is 2, 4 minus 2 is 2, 6 minus 4 is 2, and 8 minus 6 is 2. So let's take a look at the next one. Going from 1 to 5, that's a difference of +4, so it went up by 4. Going from 5 to 25, 25 minus 5 is 20, so that's a change of 20. Going from 25 to 125, well, that's a difference of 100. And going from 125 to 625, well, that's a difference of 500. So if we look on the x side, you'll notice that those values are all going up by a constant amount. But on the y side, these values are not increasing by the same amount. So that means that this one is not a linear relation. Okay, so this one is not a linear relation. Definitely not. You can see also in the example on the bottom, I'm not going to plot it out for you, but if we were to plot these points on a graph, that definitely does not make a straight line. In fact, it makes this kind of curved upward line. That's called an exponential function, and we'll look at those a little bit later on. But again, you'll notice that it's definitely not a straight line, okay? So it's not a straight line. That means it is not a linear relation. So let's take a look at the next page. There are some check questions here. I would like you to try these ones on your own since we did ones that were very similar. Remember, if the changes in the x column and the y column are the same, then it's linear. If one of them is different, it is not linear, okay? So when the graph of the equation lies on a straight line, remember if it makes a straight line, as said below here, if it is on a straight line, then it is a linear relation, okay? So just remember, straight line, linear relation. Not a straight line, not a linear relation. So you can pause the video now and do those 2 check questions on page 292. And I'm going to go ahead with the rest of the lesson so you can check those check questions, again, using the answer keys that I've posted. So let's take a look at the second example. We're trying to decide whether an equation represents a linear relation, okay? So again, there's a couple different ways we could do this. We could graph it if you wanted. I'm not going to make you graph it right now, but you might have to graph some data later. Or we could make a table of values. So let's take a look here. On the next page, they've done some of the work for us. So we're just going to use the work that they've given us here to check whether this is a linear relation or not. Okay, so they did actually graph the values here for you. We can connect them. I don't have a straight edge on me, but if you did, it would make a straight line. Okay, or again, you could look at your table of values and see if it is constant every time. So here we lost one, we lost one, we lost one, we lost one. And on the other side, we gained one, we gained one, we gained one, we gained one. So based on our graph that shows a straight line, or based on our table of values that shows that on the x side, it's increasing by the same amount every time. On the y side, in this case, it's decreasing by the same amount every time. This is a linear relation. Okay, so yes, it is linear. Let's take a look at the second one. We'll look at the table of values first, okay? So on this side, again, we're going up by +1 every time. Okay, so it's the same on that side. Let's look at this side though and see if that is constant. So 5 to 3, or sorry, 5 to 2, that's a difference of -3. If we go from 1 to 2, oh, that's only a difference of -1. Okay, in that case, we had a +1 and a +3. So that definitely is not the same. Let's take a look at our graph. If we join the points here, oh my goodness. Okay, if we join the points, that definitely is not a straight line. So this one is not a linear relation. Okay, so again, you can tell in two ways. You can tell by the table of values, okay, if they are not the same on both sides. So if this is not the same, or if this is not the same, or if our graph is not a straight line, that's how we can tell that something is not a linear relation. However, if the graph is a straight line and all of the x values are increasing by the same amount, all of the y values are increasing by the same amount, then we do know it is a linear relation. Okay, so you can go on now, pause the video here, work on those check questions below. They are going to ask you to plot the points as well. That's really good practice for you to be plotting the points on that graph. So I would suggest doing that part as well. Pause the video now, work on the check questions on the bottom of page 293. And again, you can check your work after the video is done using the answer key attached. I'm going to go on to the next page. So last little bit here that we're going to look at is we've seen that linear relations involve variables changing at a constant rate, right? So the x values were changing at a constant rate, the y values were changing at a constant rate. If we want, we can find the rate of change of a linear relation using this equation here. So the rate of change of a linear relation is the fraction. On the top part, we're going to put the change in the dependent variable. On the bottom part, we're going to put the change in the independent variable. Okay, so if you remember from before, okay, from our dependent and our independent variable, okay, our dependent is our y value and our independent is our x value. Okay, so really we're looking at our change in y over our change in x. Okay, so remember dependent was on the vertical axis, that's your y-axis, and your independent is on the horizontal axis, that's your x-axis. Okay, so let's take a look at this first example here and see if we can find the rate of change. Now, those of you that have already taken Science 10, you would have already done this. This is actually something called slope. Okay, so the slope of the line is the rate of the change of the line. So if you've done slope before, you might remember this concept. We just called it something a little bit different in science. Okay, so we're going to take a look at this last example here and find the rate of change using the data from the graph. Okay, so we're looking for the, for part A, they asked us to identify the dependent and the independent variable before we use that formula. So remember the dependent, that's found on the vertical axis or your y-axis. That's our altitude. And the independent variable is the one found on the x-axis. What's the time? Okay, so we have dependent altitude, independent is our time. So the rate of change formula is our change in our y value, which in this case is altitude, divided by our change in our independent variable, which in this case is our time. And we generally are going to use 2 points on the graph. So they've actually already given us 2 points on the graph. Those are the ones we're going to use for this example. So remember, the first point given in any ordered pair is our x value. The second point is our y value. So we're going to be using our two y values for the top. So our two y values are 240 minus our first point, which was 120, and those are both in meters. On the bottom, we're going to use our second x point, which is 120, minus our first x point, which is 60, and that was in seconds. So again, if you wanted to, you could label these as 1 and 2. This could be x1, y1, and this could be x2, y2. Okay, now for these kind of graphs, these linear relationships that show a positive slope, these are going to be a little bit easier, but when we see lines going the opposite way, labeling it x1 and y1 and x2, y2 might be helpful later on. So let's finish our equation. That means we have 120 meters divided by 60 seconds. If we put that into lowest terms, we end up with 2 meters per second. And again, since our graph is going up to the right, that means that this is actually a positive value. If our graph was the opposite and it was going down, we would end up with a negative value. Okay, so we have positive 2 meters per second. That is the rate of change. So that is representing the movement of the helicopter. So the helicopter is lifting off at an altitude of 2 meters per second. Okay, so that's how much it's increasing. So what I'd like you to do now is finish up the check question on page 295. That's the bottom of page 295. And then there is practice questions on 296, 297, and 298. So I would suggest that you now stop the video, work on those questions, and then use the answer keys to check your questions after you're finished. That is it for this week. So I wish you all a very happy Easter. Spend some wonderful time with your families. Hopefully you can make sure that you can have it as a time of prayer and remembrance of what Jesus did for us. And have a really great Easter. I will see you after your break.